Hi. So I wanted to give a recap of some of the trig functions and the unit circle. So I'll focus on the sine and cosine functions. And one way to think about these functions is that they give the coordinates for a circle where I'm looking for the x and y position at some angle, which we usually call theta. Now I've set this up in Desmos. So in black, I have the formula for a circle with radius 1. So that is on my unit circle. The purple here is just a nice indicator. And I have to use A as my slider there, but you can think of that as a theta. So the thing to remember is that my x coordinate for the circle is the cosine function. And my y coordinate for the circle is my sine function. So you can see the dotted line in red is telling me exactly what that y coordinate is. The dotted line in blue is telling me exactly what that x coordinate here is. And I even get to see the decimal expansion for these numbers over here on the side. Now, like a lot of graphing calculators, Desmos is set up to use radians for both of these functions by default. So my range of values here is theta starts at 0, in which case I have sine of 0 is 0, cosine of 0 is 1. And as I move around the circle, you can see my slider goes from 0 radians up to pi radians. I'm halfway around. Now I'm 3/4 of the way around, all the way up to 2 pi radians to make a full circle. So that is one way to visualize both of these functions. I find it very fun to move this slider around after years of giving this talk on a whiteboard, so I hope that's a little bit more illuminating than the standard version of this lecture. One of the nice things about this setup is I can immediately see in my red line, this is telling me the value of the sine function, I can see that there are actually two places on this circle that will have exactly the same sine value. They are lined up horizontally. There are two different places that will have the very same cosine value, and they're lined up vertically. And if I wanted to put in numbers outside of the range 0 to 2 pi, I'm going to go ahead and say I want this to be 6 pi. Okay, where was I? If I look to angle values that are bigger than 2 pi, so here I'm going around the circle for the first time, you can see that the sine and cosine values just wrap around because after 2 pi, I've already made a full revolution of my circle, and those x and y values are going to repeat themselves. Those are the reason why these functions have that nice periodic graph. Now, I was asked by a student if you should memorize values on the unit circle, and I would like you to have 5 values memorized. If you have these 5 down, you can figure out the rest with some geometry. So you may have seen diagrams where you've got the 3 different lines in every quadrant. We've got 12 different values to memorize. Here is a table that I like to use, and one of the reasons I like to use it is it's very easy to remember how to recreate it. So here is my table, and I'm using radians for my angle measure. And the 5 radian values I need to remember are 0 radians, pi divided by 6 radians, pi divided by 4 radians, pi divided by 3 radians, and pi divided by 2 radians. So These are telling me angle values in the first quadrant of the unit circle. And the trick to remembering this table is that every single one of the sine and cosine values is a fraction. The numerator of the fraction is a square root. The denominator of the fraction is 2. So sine starts at 0 because sine of 0 is 0. And I count 0, 1, 2, 3, and 4. And so these are all of the sine values that I need to memorize. Cosine is going to be the opposite. And I remember that because cosine of 0 equals 1. So I put in my 4. The square root of 4 is 2. 2 divided by 2 is 1. The cosine function, the special values I'm going to remember are 4, 3, 2, 1, and 0. And so all I'm doing is just counting whole numbers. Very simple. I need to remember that these whole numbers go underneath the square roots and that I need to divide by 2. But I find that to be a very handy way of keeping track of these special values. Now, if you prefer degrees, I have the same table here in degrees, and I will be posting these slides to Moodle so you can download them and use these for your own references. In degrees, my angle measures are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. But those sine and cosine values are exactly the same. So for sine, I'm looking at 0, 1, 2, 3, and 4. I'll put whatever that number is underneath the square root sign and divide by 2. For cosine, I count 4, 3, 2, 1, and 0. Now you might ask, what about the other 3 quadrants? For the other 3 quadrants, I will return to my picture. So here I am in quadrant 1. Let's set A equal to pi divided by 6. And here I have it right there. And you can see exactly 1/2 for the value of the sine. You can see 0.86 for the cosine. So that must be my irrational value there. If I wanted to have that same value over here if I was working in the second quadrant, well, you can see right away that I have exactly the same sine value over there. But the cosine value is going to have the opposite sign. So if I wanted to move to the quadrant over here, let me bring this back to the slider A. If I move my slider over here, I'm at A is about 2.6. And you can see I've got that same exact cosine value here, and now minus the cosine value. And it's going to be the same way for each of those quadrants. If I'm looking for the value of the sine and cosine functions over here at, let's see now, 90, 180, 180 plus 45 is going to be 225 degrees, then I know that I can take the sine and cosine values for the regular old 45 degrees, but now I just need both of those to be negative instead. So sine is going to be negative 1 on root 2, and cosine is also going to be negative 1 on root 2. All right, that's it. Thank you.